Hello friends, welcome back to the channel. Today we learn how dynamic HAProxy configuration work into the OpenShift. What is the dynamic HAProxy configuration? How OpenShift router works internally? What happens when you create a route? What happens when pod scale up or scale down? How to verify everything in a production cluster. Have you ever wondered what actually happens inside OpenShift when you create a route? Do you manually update the HAProxy configuration? The answer is no. OpenShift automatically detect changes, generate the HAProxy configuration, and reload the router without any manual work. In this video, we will explain exactly how it's work using a real production example. So this is the basic of the dynamic HA proxy configuration file. In that configuration file, how that configuration update automatically, how that routes add automatically, or suppose one of the route or one of the pod not working, that information how HAProxy remove from the haproxy.conf file. So here we will learn what is the dynamic HAProxy configuration, how OpenShift router works internally, what happen when you create a routes, what happen when pods scale up or scale down, and how to verify everything in production cluster. Let's get started. Here the step 1 is user create a route. Suppose developer creates the following routes. How developer create the routes? With the help of YAML file. In that YAML file, the developer write API version, kind means the route, metadata. Metadata means your route name, payment. Under spec section, we define the host means the route name, that is payment.apps.company.com. These are the example. Into kind, this is the service. Under name, what is the name of the route? Payment hyphen service. Many beginners think someone has to log into the router pod and manually edit the HAProxy configuration. So that is not a true. In OpenShift, everything happens automatically. If you are seeing in older environment, in that environment you have to create manual HAProxy, and in that manual HAProxy you have to add the each and every route in the haproxy.cfg file, and after that once you update that haproxy.cfg file, that file you have to reload, and after that once you reload that file, your HAProxy configuration is updated successfully. But in OpenShift, that things are done automatically with the help of router pod. Step 2. What happens internally? Once the route is created, the OpenShift router immediately detects it. The router then perform this step automatically. What step that router perform? Router detect the new routes. After that, find the corresponding service. Then look up the service endpoint, retrieve the pod IP address, then generate a new HAProxy configuration, and after that, once the router added entry into HAProxy configuration file, reloads HAProxy without downtime. This entry process is automatic. No SSH, no manual editing, no service restart by the administrator. This total process is happen automatically in OpenShift. Third step is architecture. These are the example of architecture. Imagine the following setup. Route. Your route is payment.apps.company.com. That route create one service. Which service? Payment hyphen service. After that, that service create a pod. Your pod is 10.128.0.10, 11, 12. These are your pods. The router automatically creates an internal HAProxy configuration similar to front-end payment.apps.com, then bind 443, use underscore backend, that is payment hyphen service, and after that create a backend payment hyphen service and balance round robin, and then we add the pod IP addresses. Who will add the pod IP addresses? That HAProxy itself add the pod IP addresses inside the HAProxy.cfg file. Like this: server pod 1 pod IP colon 8080 checks, then server pod 2, these are the IP, then pod 3, these are the IP. Notice that we never created this configuration ourselves. OpenShift generate it automatically by itself. No manual work we have to do inside that pod router. When you create a route and that route create a services and that services create a pod, and that pod information automatically added into the HAProxy.cfg file. For this, we call the dynamic HAProxy configuration generation. Now move to the step 4, pod scaling scenario. Now imagine traffic increases. Web scale, sorry, we scale the deployment with the help of which command? With the help of OC scale deployment payment hyphen hyphen replicas is equal to 5. Earlier you see pod 1, pod 2 and pod 3. Then after scaling you see pod 1, pod 2, pod 3, pod 4 and pod 5. See, after scaling you will see your pod has been increases 3 to 5. The router continuously watches the cluster As soon as the new pod becomes ready, endpoints are updated, HAProxy configuration is regenerated, the new pod immediately start receiving the traffic. Here, no manual reload is required. All are happens automatically in OpenShift with the help of router pod. Suppose scenario number 5, pod fail scenario. Now what happen when your pod is failed? Will HAProxy remove that information or that configuration from haproxy.cfg file or not? Let's see. Suppose pod failure. Now you have the 5 pod. Suppose pod 2 crashes. Earlier you see pod 1, pod 2, pod 3, pod 4 and pod 5. After crash, you only see pod 1, pod 2, pod 3, pod 2 we haven't see here. Why? Because that pod 2 is crash. So here we see pod 1, pod 3, pod 4 and pod 5. The endpoint object automatically removes the pod 2 here. Here we are not removing manually pod 2 configuration entries from the haproxy.cfg file. But in the OpenShift, suppose any pod crash, so that endpoint entries automatically remove from the configuration file. The router detect this change, HAProxy configuration is regenerated, traffic immediately stop following to the failed pod. This provide high availability without administrator intervention. So these pod removing activities also happen automatically by the OpenShift. Step 6. How does the router known? Means suppose we are adding or we are scaling any new pod, or we scale down any pod, or our pod has been crashed. How does the router knows? A common interview question everyone asks into the interview. How does the router knows about these changes? The answer is the router continuously watch the Kubernetes API server. How the router continuously watches? Its monitor routes, services, endpoints and TLS secrets. Whenever any of these resources change, the router automatically regenerates the HAProxy configuration. This is called the watch mechanism. So, with the help of watch mechanism, router identify the changes inside the HAProxy.configuration file. Now move to the step 7, production verification. If you are working in production, you can verify this yourself. Connect to the router pod. How you will connect to the router pod? First, we check the pod with the help of OC -n OpenShift ingress. Then connect to our router pod with the help of OCRSH and your router pod name. Then check the HAProxy configuration file with the help of cat where-lib HAProxy conf haproxy.config. These are the config file. Now create a new route or scale a deployment. To check that configuration file is automatically regenerated or updated or not. Once you scale up the deployment or adding any new route, run the command again. You will notice that the HAProxy configuration has changed automatically, and that's the proof of dynamic configuration regeneration is happen through the HAProxy configuration file. Now we are seeing the interview questions. Many interviewer ask this question into the interview: what is dynamic HAProxy configuration in OpenShift? The answer is, in OpenShift Router continuously watches routes, services, endpoints and TLS secret resources using the Kubernetes API. Whenever a route is created, pods are scaled or endpoint changes, the router automatically regenerates the HAProxy configuration and reload HAProxy without manual intervention. This process is known as dynamic HAProxy configuration generation. So these are the steps you have to explain into interviewer. The very short answer is, OpenShift automatically converts the routes, services and endpoint information into HAProxy configuration and update it dynamically whenever the application changes. I hope this video help you understand one of the most important OpenShift interview concept. Today we learn how that dynamic HAProxy configuration work itself in OpenShift. If you found this video helpful, like the video, comment your question, subscribe for more OpenShift, Kubernetes, Linux and DevOps production tutorial. Thank you for watching, and I will see you in the next video. Bye bye.